Okay, greetings, welcome back everyone. Good to see you all. Hello, yes, hello. Okay, so we're a little bit ahead of schedule, which is good. So we're going to get into integration over general regions, we're going to get into some distinctions about that, and then in our Friday section, we're going to talk about change of variables. Okay, so we're a little bit ahead of schedule. I just want to say where we are in the book. So if we go double integrals over general regions, then there's lots of discussion of the following distinction, and I always find this distinction super duper tricky. Just want to go over this part very slowly. This distinction between type 1 regions and type 2 regions. So sort of a funny story about this. Last time we taught the course, there were 3 professors. There was me, Professor Mike Paliuk, and Professor Bill Weiss. And Bill Weiss called them north-south regions. I called them type 1-2 regions. And then Mike called them type 2-1 regions. So every single section had a different convention on this. So I'm being very mindful and intentional to do exactly what the book does with regards to these distinctions. Okay, so our definition is that something is of type 1 if we can write it as being bounded by 2 functions. Okay, so if there's a continuous function g1 and a continuous function g2 that cut out our region D. Okay, so this lower graph here is the graph of g1, and the upper graph is the graph of g2. So I want everyone to just take their head and say type 1 region, like this. Type 1 region, up and down, bounded up and down by our functions. Okay? Type 2 is this, but in the y direction. So same kind of picture. We have bounds on one coordinate and functional bounds on the other coordinate. So now the hand gesture is type 2 region. Type 2, very good, yes. Right? Type 1 goes with X. Type 2 goes with Y. Hopefully that lets us keep track of this distinction. Okay. So there's a couple exercises classifying regions into type 1 versus type 2. So we'll look at those, see what those guys look like. Okay, so some of the homework exercises say, specify whether the region is type 1 or type 2. Okay, so we look at this region, the region exercise 60. We say, aha, it's bounded by x and x equals 0, x equals 1. It's bounded like this, so we're like this, so we're type 1. Here's the, you got this? Cool. Here's another sketch of a region. So we look at it, we say it's bounded by x equals 0, x equals pi by 2, so it's bounded vertically in x, so we're type 1. Aha. Now the skill testing question. Is this type 1 or type 2? Yes, get the hands out to do some kind of. I'm getting a couple peace signs, a couple type 2s. Anyone think it's type 1? Type 2? Type 2? Okay, hands up for type 2. Hands up for type 1. Oh, interesting. Very interesting. Okay, so it looks like it's type 2, right? We've got that it's bounded by y equals -1, y equals +1. Okay. Very good, very good. Yeah, we're bounded by, or we're vertically bounded by -1 and 1, so we are type 2. What do we think here for this graph? 2, yeah, good. Type 2, very good. Anyone think it's type 1? Yeah, it's both. Yes, so it's both bounded by x equals -10, x equals 10. Right, we're bounded by we're bounded in x, and we're also bounded in y, from y equals 0 to y equals 10. So this region is both. Okay. Similarly, this region will be both type 1 and type 2. Both type 1 and type 2. We don't have any examples that are neither. I guess that's sort of neither. So there are regions that are type 1 and not type 2. There are regions that are both type 1 and type 2. So whenever you learn a mathematical distinction, it helps to come up with all possible cases of that distinction. Okay, so if you've got sort of two distinctions simultaneously, you can make this square of all possible pairings of those distinctions. So what would be something that's neither type 1 nor type 2? What's somebody that would fit in this box here? Take a moment and try and draw an example of something that would live here. Seen a couple examples of things that are both, right? If we had a nice round circle that would be bounded by functions in the x direction and functions in the y direction. So we've got an example for things that are both. It's harder to come up with things that don't have this property. Right? We have these continuous functions that bound our region on both sides. So one of the ways that we can prevent this or break this is by having some discontinuous jump in our region. So if we want to be type 1, we're going to be bounded by x and y. Right, so we can be bounded like this, but we need some kind of jump that will make us not be type 2. Try and find something in one of these boxes, that is neither type 1 nor type 2. one of the things we can do is we can make a hole in our region. Right? Notice that type 1 and type 2 regions can't really have holes in them because they need to be bounded all the values between two functions. Okay, so if we introduce a hole in the middle of our region, we can't write down that hole with boundaries as functions. Anything in either of these boxes, any progress here? See that we are monumentally stuck. So let's leave it. Let's sort of table that for a little while. Okay. We introduced the notion of integration over general regions. Right, so this is the double integral of a function over region A with respect to area.